Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Under acid-catalyzed conditions, a 1,2-diol reacts with an aldehyde, PHCHO, to form a cyclic acetal known as a 1,3-dioxylene. This is a classic protection condensation reaction of vicinal diols with carbonyl compounds. Moving on to the next step. The starting material is a vicinal diol, 1,2-diol, where each hydroxyl-bearing carbon also carries a 2-methylcyclopropyl group. PHCHO is benzaldehyde. The conditions are H+, acid catalyst. Moving on to the next step. Under acid catalysis, the aldehyde is activated, protonated, and the diol acts as a nucleophile. The two groups of the 1,2-diol condense with benzaldehyde to form a 5-membered cyclic acetal, 1,3-dioxylene. One molecule of water is lost. The product is 2-phenyl 4,5-bis 2-methylcyclopropyl 1,3-dioxylene. And for the final step, the product has a PHCH bridging to oxygen atoms, which are in turn each connected to one of the original diol carbons, each still bearing its 2-methylcyclopropyl group. This matches option B, PHCH, OO, with the 2 oxygens forming a 5-membered ring with the 2 carbons bearing 2-methylcyclopropyl groups. Option A shows a CH, PH, directly bonded to the central carbon without oxygens. This would require a C to C bond formation, not the expected acetal chemistry. Option C shows an epoxide product, which would require loss of water from the diol alone without involvement of PHCHO. PHCHO would not be incorporated. Option D shows an alkene, dehydration product, which does not incorporate PHCHO and is not the major product under these mild acetal forming conditions. The 96% yield strongly supports the thermodynamically favorable cyclic acetal formation from a 1,2-diol and an aldehyde under acid catalysis. Therefore, the correct answer is B. Therefore, the correct answer is option B.